Good evening. Welcome to the Space Telescope Science Institute in Baltimore. I'm Don Savage, Public Affairs Officer for NASA's Office of Space Science. This evening, we're pleased to announce the start of a week-long campaign of observations of the impact of periodic comet Shoemaker-Levy 9 with Jupiter. The impact of the first fragment occurred earlier this afternoon at about 3:54, and scientists around the world participating in the NASA National Science Foundation observing campaign, as well as virtually every other telescope and observatory around the world, have been watching. That included, of course, the Hubble Space Telescope, which is where we are located here at the Institute. An image of the area of Jupiter, which the fragment hit, will be ready by about 10 o'clock tonight. And at that time, Dr. Heidi Hamill will provide the image, and we'll discuss what you can tell from the early analysis of the data. Now, I'd like to introduce our panel, the discoverers and, of course, the namesake of the comet. From my left, Dr. Eugene Shoemaker of Lowell Observatory. He's a research professor at North Arizona University in Flagstaff and scientist emeritus at the U.S. Geological Survey. To his left, Dr. Carolyn Shoemaker, his wife, also a staff member of Lowell Observatory and research professor at North Arizona University and a volunteer scientist at the U.S. Geological Survey. And on the far left, David Levy, amateur astronomer and author, and he's discovered 21 comets and in 1984, 8 in his own backyard, and 13 working with Gene and Carolyn Shoemaker in Mount Palomar. Dr. Shoemaker?
Thanks, Don. Well, it's a great pleasure to be with you this evening. We're here to start the reporting on a campaign that's been 16 months in preparation since the discovery of the comet. We were very fortunate to be able to discover this comet far enough ahead of time that astronomers around the world could actually plan carefully an observing campaign, get their observing requests into observatories, and of course a campaign has been carried out and is being carried out with the Hubble Space Telescope, which is guided from here. As the planning is done from here. The Hubble has been very important actually in obtaining some of our best images of the comet over the course of the past year, actually starting July a year ago. And I think we're very lucky, of course, to have the new improved optics on Hubble, which are going to prove their worth tonight and through the rest of this week. Not only have observers been preparing, but there have been several teams of theorists around the world, mostly in the U.S., who've worked very hard to try to predict what the effects of the impacts of the comet fragments would be. And what I want to show you very briefly is what I regard as the latest and best prediction for the eruptive plume that will be formed by an individual comet nucleus of a kilometer diameter plunging into the atmosphere of Jupiter at 45 degrees. The work I'm going to show you actually has just been completed. It's a team effort primarily carried out by Paul Hassig at Titan Research Corporation, who's a close colleague of ours, my colleague David Roddy. I have two Davids in my life. David Roddy was my first graduate student and is a colleague of mine at the USGS. And Andrew Ingersoll, who's a professor at Caltech. And I think that we have probably the best simulation on the computer of a plume that will erupt from beneath the cloud tops. If we can now roll the images, we're starting and we're going to go. This is 1.5 minutes, if we can keep rolling. This is 2 minutes, and the plume is growing. This is now 3 minutes. It's rising to a total height of about 700 kilometers. This is at 4 minutes. The color, it's getting cold at the top. Oops. What happened there? All right, let's continue with the next one. Is that the last one? I don't know where a live signal came in there. All right, I guess that's as far as he can take the... There we go. The plume gets very cold and then finally falls back down. You may not be able to see the dimensions in that block diagram, but the plume spreads out more than 2,000 kilometers across. And it rises to a height of nearly 1,000 kilometers at its greatest extent. It reaches that greatest height in about 5 minutes. Now, having done those calculations, it gives me great satisfaction to be able to tell you that there have been 2 reports received at the University of Maryland, one from an observing team in Calar Alto in Granada in Spain, headed by Tom Herbst and 6 other astronomers, observing with a 3.5-meter telescope and observing in the 2.3 micron band. That's an absorption band of methane, so that Jupiter becomes very dark in that band. That's the best band to observe at if you want to see something bright that's rising above the cloud tops. And they did, in fact, detect the plume at 2:18 Universal Time, which is 18 minutes, essentially, after the predicted time by Paul Chodos and Don Yeomans at JPL for the impact. Now, remember, it took about 5 minutes for the plume to reach its full height, and at about that time, the plume actually would be rotated fairly close to the limb. So I expect that the prediction is the actual impact probably was about 13 minutes after the predicted impact, but that's very good because the standard deviation of prediction is 8 minutes, and so it's about 1.5 standard deviations off the prediction. That's a very good prediction from the astronomical observations. So it looks as though it was seen on the limb of the planet, and in fact it was reported, the plume is reported to be brighter than the satellite EO in the 2.3 micron band. Now, we should all take these reports very carefully and cautiously at this time. They need to be confirmed by other observers, but I'm very happy to tell you the plume is also reported to be observed in the 10 micron band by observers, again with a 3.6 meter telescope at this site, and this is a 10 micron observation, which is also deep in the infrared and also spectral region in which Jupiter is not too bright to begin with, so it's easier to see the plume there. So the plume independently has been seen in Chile as well as in Spain. So this is the moment of truth. We have all speculated and tried to estimate the sizes of the nuclei, and we've worried if the nuclei were at the smaller limit, which is set actually by the dynamics. The parent body could not have been much smaller than about 2 kilometers, so the biggest fragments, if there are single fragments, would likely have been only a few hundred meters across, versus the other possibility, the upper limit was set by observations with the Space Telescope last July and then later this year, allowing the individual largest fragments being about 3 or maybe the largest 4 kilometers across. We've assumed that maybe the best bet somewhere in the middle at 1 kilometer, but now remember we're observing fragment A, which is one of the small fragments. So I think there's very good news tonight. If these reports are correct, then you can expect a good show for every telescopically observed nucleus. We're going to see things and we're going to learn a lot. That's the good news tonight. Let me now turn the podium over to my wife, Carolyn. We'll talk a little bit about the discovery.
The discovery of Comet Shoemaker-Levy 9 was terrifically exciting in March of 1993. At that time, to discover something like this was completely unbelievable to any of us. It was a dark and stormy night, to quote a famous phrase, but it was a dark and stormy night on which this comet was discovered by us and by a young Frenchman, Philippe Benjoya, from Nice, France. This was discovered in the course of our normal work as part of our routine survey. Happily, it was a field that we were able to take in spite of the fact that a storm was moving in. We took the films for this 2 nights before discovery, and at that time we were very grateful that we were able to take anything. We had had a bad 2 months of winter during which we took very few films. So when we had the chance to take any films that night and took this particular pair, we were uncommonly lucky. I searched these films 2 days later in my usual way, but maybe I should back up a little and tell you, how does this team work? First of all, there's the telescope in the 18-inch dome, which is the oldest telescope on Palomar Mountain. It is Palomar Mountain, not Mount Palomar. This is an 18-inch Schmidt. It's a camera. And we take pairs of films of one field. By taking pairs of films of one field, I can look at them under a stereo microscope and detect images that appear to float in a 3D effect. The stars lie down nice and flat. The galaxies lie down nice and flat. Asteroids and comets appear to float. It's a wonderful technique. During our night of observing, David and Jean are usually up on the observing floor. One of them is guiding this telescope, which is open to the sky. It's a very old-fashioned technique that isn't used much anymore. We actually do see the sky as we observe. One of them is on the telescope guiding. The other one is busy putting the person on the telescope on the right field, changing the film, going up and down stairs, and then setting up, helping set up the telescope for the next observation. Every 4 fields, they take their own turn in one changes and gets on the telescope, and the other one does the running up and down the stairs. After about 8 fields, I usually develop the films. And after I have finished developing the films, I scan any of those that are dry. So that's our general procedure. But on that dark and stormy night, we were not able to do that sort of thing. I was scanning fields, trying to catch up with what we had already taken. And the others were doing their usual thing. David writes books. Jean was busy with office work of some sort, and Philippe was also there. And I was trying to be careful. If I clear my throat or cough a little, they all snap to attention and say, "What have you found?" Well, that night I had just finished my usual litany when I'm beginning to feel desperate. I was at the end of coming close to the end of the films that we had taken. And I turned to David and said, "I used to be a person who found comets." And then that usually helps a little bit. And I started to scan the field that had Jupiter on it. For me, that's been a lucky field. I found another comet on a Jupiter field once when I was busy confirming a comet for another observer on that same field. So I was hopeful that maybe, just maybe, something would turn up. And sure enough, halfway down, after I'd come across Jupiter and after I'd seen Jupiter's ghost image on the film, there was a strange-looking object. I almost went past, and then I said, "Whoops, I should go back to that." And I moved the film back and looked harder and decided that's not an edge-on galaxy, because we see galaxies face on, turned a little cockeyed, edge on. But this was not an edge-on galaxy. It had coma and tail, and most importantly to me, it floated. It had to float, or I wouldn't have seen it in 3 dimensions. And so I knew that was a comet. I always have this deep inner feeling when I find a comet. If I have to wonder, it isn't. In this case, I knew I had a comet, but it was strange looking. It looked like a bar. Instead of the usual round halo with an atmosphere or coma and a tail, it was a bar with coma and tail. And I thought that's not natural. I turned to the others because I always bring them in on any discovery as soon as I can. It takes all of us working very hard all of the time to make these discoveries. And it's their discovery as much as mine. I'm just lucky enough to have seen it first. But I wanted them to see it right away. And furthermore, I wanted them to tell me why it looked like a bar. I turned and said, "I don't know what I've got, but it looks like a squashed comet." And they really snapped to that time. And Jean rushed over and looked at it and looked very puzzled. And then David took his turn and was equally confused, and Philippe took his turn. He was interested in part because he had been studying for his PhD in France, not so much the breakup, but families of asteroids, which would be caused by breakup. And we were very, very bemused by all this. We couldn't imagine what it was. As David often says, our brains sort of turn off for a minute. We get a rush of adrenaline, and we were excited, and we thought, we found something unusual. So that was the beginning of this wonderful event that has led to a culmination tonight. During this time that has ensued, we had a vast amount of surprise and excitement when we first of all discovered that the comet was in orbit about Jupiter. That was a first ever. And then a couple of months later, when we discovered that this was a comet that was going to actually impact Jupiter, a first ever, a comet seen impacting a planet. That was really exciting. I was a little dismayed, I'll have to admit. I thought I would never lose a comet in such a fashion. I was actually going to lose one of my comets. And that was a momentary bit of sadness. And then I thought, oh, but how exciting. Everyone will get to see a comet hit Jupiter. But at that time, I had no conception of all that was going to ensue. I had no conception of how much all of us stood to learn about comets, about a planet in our solar system, just from the discovery of this particular comet. And that, to me, has been one of the more exciting things, to see people from many different areas and disciplines of planetary science and astronomy come together with their knowledge, work together to get the most out of this. So that has been a wonderful thing. And then this afternoon, about the time that I knew that comet was going to hit Jupiter, fragment A, I suddenly discovered I had a real emotional attachment to this comet. During all this time, it's been a thing of great beauty to me out there. The first images I saw after Jim Scotty showed us his, and after I saw Dave Jewett and Jane Liu's images from Hawaii, just captured my imagination, and that image has been there ever since. And yet, here it was, fragment A was going to hit Jupiter. And I'll have to admit, I had a momentary tear at the very prospect when I knew that moment had happened. Well, that's gone. But just a few hours later then, the sudden news of actually seeing something from Spain and from Chile, that's terrifically exciting. All I could say was, right. And so that is one of the phases of this whole cometary experience, I think, that has been wonderful for all of us. Now, I'd like to turn the meeting over to David Levy, who is a well-known writer, particularly about astronomical things, a lecturer, and a very close colleague. David.
Thanks, Carolyn. That is a tough act to follow, what you just said. Congratulations. I think the exciting thing about tonight is that once in a generation, we get one of those, if we're lucky, we get one of those rare moments when science stops for a moment, turns on its ear, and gives us something really, really special. In the early 1950s, the discovery of DNA did so much to, it was a discovery, and we learned an awful lot. But the real thing that discovery did was that everyone who was young at that time looked at all the news about the discovery, studied it, and they said, science is fabulous. You can uncover the mysteries of life when you get discoveries like this. In 1969, there was the Apollo 11 moon landing, almost exactly 25 years ago. that another generation paused for a moment. I remember at a summer camp in Lake Placid, we had about 160 people watching a television set about this big, watching that first small step take place. And the youngest people in that audience couldn't have been 7 years old. And the entire camp was there for 4 hours, and nobody said anything. Everybody was absolutely quiet because we knew that this was one of those moments. There have been other moments as well, but I'm really beginning to think that the impact of a comet on Jupiter can be one such moment, a moment with the power to have science say to the world, it's fun to study science. Nature every now and then throws us a real ball that we can shoot out of the park. And I think this is what's happening here. Cometary impacts have had enormous influence on our past. It is very likely that cometary impacts provided the water that is on the Earth right now. It is likely that they provided the building blocks of life, the simple alphabet of life, C-H-O-N, carbon, hydrogen, oxygen, and nitrogen. A comet hitting the Earth, maybe an asteroid, hitting the Earth 65 million years ago probably led to the demise of more than 70% of the species of life on Earth, including the dinosaurs. We have seen the results of comet impacts. I think we being here is one of those results. We have seen, if you go outside and look at the moon on any clear night with a pair of binoculars, you'll see enough craters, impact craters, that Gene has studied in his life, that you will be able to see that the Earth and the moon have been hit by craters throughout their history. We've seen all this. We understand a little bit about it. What we haven't seen is an actual impact take place. I'll never forget May 22nd. It was my birthday. We were all at Palomar Mountain. Carolyn is scanning for comets. It is actually a scan that would have proved successful in the next few hours when she found our next comet. Gene was in the darkroom getting ready for our observing that night, and I was checking the mail to see if there were any interesting objects that we would have to observe that night to follow up new discoveries, things like that. And I logged into the email. There were 2 circulars from the Central Bureau for Astronomical Telegrams, and I read the first one, and my jaw fell on the floor. It announced that there was a good possibility that comet Shoemaker-Levy 9 would be hitting Jupiter in July of 1994. And I said that. I said, our comet's going to hit Jupiter. Gene has spent his entire life studying impacts, from his PhD thesis to prove that meteor crater was the result of an impact, from the work he did on the Apollo program, from the work he's done for the last 15 years, studying not the craters so much as the objects that sometimes make the craters, the comets and the asteroids. And here, he is in the darkroom, and I just told him that we're going to see an impact on Jupiter. And I heard this slamming of doors and closing of lids as he's trying to save the film before he throws the darkroom door open, pushes me out of my computer chair, and sits down, looks at my screen and says, I don't believe it. We are going to see an impact. And since May 22nd of last year, it has been just one excitement after another. This is not a comet just for the professional scientists. This is everybody's comet. We've heard a lot that you're not going to see anything with the small telescope that you buy at a store or that you build yourself. That's true. You're not going to see Jupiter show major changes from this impact, but you don't have to. That's why we have a fabulous Hubble Space Telescope. That's why we have the large telescopes on the ground, and that's why we have television to transmit those pictures to everybody. What we do have to do is to go outside with small telescopes, binoculars, and just look up at Jupiter. With a pair of binoculars, you can mount it well against the wall of a building, you're going to see the moons of Jupiter revolve around that planet. Not in one night, but if you look every night, you'll see them in different positions, just like Galileo did in 1610. With a small telescope, you're going to see the bands of cloud around Jupiter that are part of Jupiter's atmosphere. The bigger the telescope is, the more of those details you'll get. The important thing is, if you make those simple observations, even if you have no pair of binoculars, just go out and look at Jupiter each night. You'll see it move slightly relative to the stars. These are observations anybody can make without any telescope, anything, to just look at Jupiter. It's high in the southwestern sky these evenings, very bright, the brightest star in that area, the brightest planet in that area, the brightest object in the sky, in that part of the sky. And this way, everybody can be a part of this event. You'll be able to look up at Jupiter and say, I saw Jupiter the week the comet hit. And then you come inside, see the results on Hubble Space Telescope, later on the Galileo spacecraft. We are so extremely lucky that the impact, which might take place once a century, it might take place once in 1,000 years. It's rare. But with something taking place that infrequently, it could have happened last year. It could have happened 15 months ago. If it had happened last year, Galileo was not in the right position to observe it. We would have seen nothing. If it had happened 2 years ago, if it had happened just maybe last November, we wouldn't have seen as much as we're getting now. It's happening tonight. We have a fully repaired and healthy Hubble Space Telescope, which has been performing like a jewel in the last few months. The Galileo spacecraft, despite the antenna, is producing fabulous discoveries. The moon on the asteroid Ida, the moon circling Ida is one of them. This is a time when we can really look back and say the 25th anniversary of the moon landing is a real time to celebrate, because we have such good instruments to observe the most fantastic event that we've had in a long time. This is an event, I think, that has the power to generate a whole lot of interest in science among people, especially young people. People have asked me more than any other question, what will this event do to us on Earth? And I start by saying, absolutely no effect on Earth. Jupiter is 500 million miles from here. Don't worry about it. And then I think about it for a minute. I hope this event has a powerful effect on Earth. I hope this event will make people think that the sky is a wonderful, user-friendly place to watch, and that science is not just done by professional scientists. Science is fun, it is alive, it is telling us things that are important in the here and now. If SL9's crash into Jupiter does that, I think it would really have made the best contribution of all. And now, Don, back to you.
Thank you. I'd like to open up now to question and answers from the audience here, and then we'll take Q&A from the NASA centers. I would like for reporters to please wait for the microphone to get to you and then state your name and affiliation. Take one in the front row.
Hi, Shin Yoshikawa of NHK. I think it's a little bit too early to ask you about this, but how deep was the collision, and what was how the energy look like, and from this two results, what's this comet look like? It look like an asteroid, or it look like a snowball or something? Can I ask your estimate?
I guess you asked me several questions.
Right.
The first question was, how deep did the comet penetrate into the atmosphere of Jupiter? Well, of course, we don't know that yet for nucleus A. For the simulation that I showed you, this was for a 1 kilometer diameter body with a density of ice, and it was essentially decided using what knowledge we have of the fragility of the comet when it broke up, that we would have it come apart at 31 kilometers below the cloud tops. That's a somewhat arbitrary decision, but we think it's fairly representative. But we did let the comet go right through and stay intact, punching a tunnel into the atmosphere on the computer, of course. And then it comes apart and dumps its energy and creates a very hot fireball that expands and then rises buoyantly. If you were to watch the evolution of the plume, part of it does shoot back out along the tunnel, but most of it just rises buoyantly and just bursts right out above the cloud tops. So I think that's the answer to the first question. Now, the second question was, is this more like an asteroid or... Well, or maybe you're asking, is it a single solid object or is it an accumulation of many smaller pieces? Is that your question? That's still the $64 question. There are two very important reports. One has just been published in Nature, and a second one has been submitted by an author who's here in this room, I think. I don't see him just at this moment. Both showing that you can explain the number of objects that we see in the string of pearls if the original parent body was simply a loose agglomeration of many, many smaller bodies. And theoretically, it turns out you should get just about 20 pieces when it breaks up, and then the 20 individual clumps. But each clump itself is made of many smaller pieces. This looks like a very reasonable proposition. In fact, is Rettig here? I don't see him at the moment. He's here at the Space Telescope Science Institute. And the other authors are by Ashfog and Bentz, who published in Nature. I think it's a very persuading argument. In fact, I would venture to say that a general view of comets is in the process of shift. I think we're going to see a paradigm shift from the point of view where people have been thinking of comets as sort of one big dirty snowball to really just a collection of finer debris, just loosely held by gravity. I think a lot of people are now starting to think very much in that direction, and the evidence is coming, of course, from the breakup of periodic comet Shoemaker-Levy 9.
Work for Reuters. Have any of you seen any images of the impact site? If you have, what were you looking for and what did you see? Have you seen anything from Hubble yet? If you haven't, when are you going to see it?
Well, let me answer for the team. Stick around till 10. We've not seen the images yet. They're coming down, and Heidi Hamill will report on that in about 2 hours.
One quick follow-up. What will you be looking for when you see these images? I know you have that model that you showed us, but what are you going to be looking most assiduously for when you see those images from Hubble?
A new spot on Jupiter. And in fact, I don't know if I mentioned it, the intensity of the brightness of the spot as reported from Calar Alto in Granada was greater than the brightness of Io in the 2.3 micron band. Where I hope very much that the Hubble images that are going to be seen later tonight will actually define the dimensions and the brightness of that spot in various wavelengths very well. So this is very exciting. Stay tuned. None of us up here have seen those images yet.
Excuse me, Jane, could you put your mic down just a little bit? Yeah. Okay, question in the back.
O'Mara from Sky and Telescope. Brian Marsden recently mentioned that he thought that such impacts probably happen in the order of decades. Given this recent observation of this small fragment, do you think that that's possible that such a feature would go unnoticed?
Do you want to answer, David?
It's hard to say. I haven't seen, based on our previous question, I haven't seen the pictures yet. Based on the descriptions that we've read, it's looking really like fragment A. Fragment A is one of the smaller fragments, one of the smallest ones. And its importance is only in that it's the first one. And if it has really produced so far, based on ground-based images, what it seems to have produced, it's looking like the original comet would have been closer to the larger size, the larger end, closer to that 10-kilometer diameter for the original body. It's still too early to say that for sure, but if that's the case, then I would suggest that this would be a much rarer event than that, maybe once every several hundred, maybe 1,000 years. What do you think?
My best guess is if the precursor were 10 kilometers across, and the fact that we're seeing such a bright spot, if these reports are correct, there has to be a caveat there.
Yeah.
We have to get
That's
proof
a big
of
if.
this. these reports are correct, then I think the 10-kilometer size, as David says, looks reasonable. And my guess is that you don't get a hit by a 10-kilometer object more frequently than about once 1,000 years. I think we may be privileged to witness one of those very rare events in astronomy.
And there's something else, though. This is the second act of a two-act play. Well, it's the second act of a play that is at least two acts so far. This is the frequency for just an impact. What is the frequency for the comet to do this weird celestial dance around Jupiter, breaking up 2 years before impact, brightening up so that it could be discovered and we could plan for this thing? How do we factor that into the equation?
That makes it still more rare.
I think there's one other factor, and that is that you could have an event like that on Jupiter, but if no one is looking, you're not going to see it. Jupiter is not always the center of attention, and unless one looks at the right time, you saw the simulation. That dies down fairly quickly. You might not notice another white spot very soon.
But this is a little premature. We haven't seen the data from Hubble Space Telescope. We're basing this on 2 initial reports, and they're reliable reports. But there's that big caveat. We want to see more. We all want to see more. But it's looking pretty good right now that we're seeing a rare event.
I just make one other comment, Steve, and that is that I think Marsden was arguing simply from a probabilistic standpoint. What are the odds that we would be lucky enough, like Tycho, to see the once per millennium supernova? The odds, a priori odds, are that if we're going to see something at all, it's much more frequent, and that would be consistent with the impact of, say, something like a 1 or 2 kilometer body or a parent body rather than a 10-kilometer size.
Since Jupiter...
Name and affiliation, please.
Oh, sorry. Linda Howe, Chancellor Communications, Philadelphia. Since Jupiter is a planet that is largely made of hydrogen gas, what prevents the large plume explosions from spreading planet-wide?
Do you want to try
Well, I can try that. Hydrogen, as we know, is very flammable, but you need oxygen to keep the combustion going. And Jupiter, the hydrogen is just there all by itself, just sitting there, very cold. And it's as inert as stale bread. So I don't think so. As far as another question related to yours, because so many people watch 2010 these days, these comets are far too small by many orders of magnitude to start any nuclear fusion from taking place inside Jupiter. That's not what this is about at all. So Jupiter's not going to catch on fire. There's no oxygen to support that. Did I do okay?
I'm not, was that the sense of your question?
Well, any kind of explosion. It could be either way. I wasn't thinking necessarily of a nuclear explosion like a sun, but just what would keep the hydrogen from continuing to explode and explode if they are going to be massive, as you've demonstrated here. Why wouldn't it just keep exploding with more and more hydrogen?
Bear in mind what's happening. It's not that the hydrogen is burning or that sort of thing. It's just that a tremendous amount of energy is dumped into the atmosphere of Jupiter by a very strong shock wave, which heats the atmosphere up to several tens of thousands of degrees Kelvin. So it's exceedingly hot in a very small region. That's simply because you have a body coming in at 60 kilometers per second, and in a very short distance releases all of its kinetic energy. So all you're really doing is just, you're point heating almost the atmosphere, and what causes the eruption, the plume, is that just expands and becomes a buoyant bubble that blows out the top.
In the second row.
Gene Shoemaker, Glenda Chu from the San Jose Mercury News. I wonder if you could repeat the bit of news that you had this evening about the 2 observatories that actually think they have spotted plumes. Where are those, and what are the names of them? And if you could spell them, it'd be all to the better. Okay. And the names of the scientists who are in charge there?
I could give those to you, yes. The first report that was received was from Calar Alto, which is in Granada, Spain, C-A-L-A-R, second word A-L-T-O. The observers were Tom Herbst, H-E-R-B-S-T, Doug Hamilton, Jose Ortiz, Herman Buhart. I have it down as B-O-E-H-H-A-R-D-T. I hope I transcribed it correctly. Karl Heinz Mandel, C-I-R-L-H-E-I-N-Z, Mandel, M-A-N-D-E-L, and Alex Fiedler. And they are observing at Calar Alto, Spain. The second report, this is from a 3.5 meter telescope. It's a big telescope. The second report is from the Nordic Optical Telescope at La Silla, Chile. The report was relayed on by Richard West of the European Southern Observatory, but I do not have information on who the actual observers were. I'm sure that that will become public very soon. Two words, L-A and S-I-L-L-A. Pardon me? The time reported from Calar Alto, the plume was observed at 20 hours, 18 minutes universal time versus a predicted impact time of 20 hours even by the JPL team of Paul Chodas and Don Yeomans.
That means that the predictions from Chodas and Yeomans were really
They're very good.
Extremely good.
We'll take one more question from here, go to one of the centers, and then come back. Go ahead.
This is NHK. At 10 o'clock, we're expecting images in the visible light range from Hubble. And we're curious about some of the other areas that have been explored in terms of the spectrum. Have you heard of reports from in the infrared range, ultraviolet, even perhaps in the radio telescope areas as well?
There has been a report that's come over the news wires from Japan. Let's see, is Miles here? Don't see it. This is a report by the Japanese observer, not familiar to me, in the radio region, reporting, and it's not specified as to the wavelength region, that the radio emission from Jupiter, this is already before the impact of fragment A, it's about a day ago, has increased by a factor between 10 and 100. But I've not seen any details on that. So that's the only thing I know of in the radio region. I expect we're going to see a lot of reports coming in the next 24 hours from radio observers. I'll be very surprised if we don't see discrete pulses from these impact events. That's all I know of at the present time. So actually, we only knew of these things a couple hours ago, so it's all very fresh.
I'd like to go to, excuse me, please. We're going to have to take a question from the Johnson Space Center now, and we will come back for more questions here in a moment. Johnson, are you on the line? Name and affiliation, please.
This is Dan Feldstein from the Houston Post, and I was wondering, you've heard the two reports that they have seen a plume. I was wondering, have you heard from people who were looking and did not see anything? And have you gotten many of those, or could you characterize how many folks called in and said, I didn't see anything?
I've only heard about fourth hand that people have tried to observe in the visible region of the spectrum without success, but I have no real reason to believe that that's strongly based. I just don't know.
Yeah, we just checked the email just before coming here, and there didn't seem, the only two reports we got were those two positive ones. We did not get any negative ones. I know that some of the sites did report that they were cloudy. But I haven't received any other reports.
We'll take one question from Jet Propulsion Laboratory in California. Go ahead, please. Name and affiliation.
This is Robert Lee, host of the Los Angeles Times. I wonder if you could tell us, based on the sketchy preliminary observations that you've had reports on, whether the plumes that were observed bear any resemblance to that interesting simulation you just ran for us.
Well, my interpretation, and this is really, you have to be very careful now because we're working with very little information, but in order for the plume to be seen at all, it has to be, in fact, at the time given, it would be very near the limb. And I think it would be very consistent with the simulation that I showed to have a plume rising up to about 1,000 kilometers above the limb to be visible and to be as bright as it was reported. But we've got to see lots more.
No follow-up at JPL, then we'll come back here to this Telescope Institute. Question in the back there.
Am I up?
Go ahead.
Yep. This is Alan Mayerson from National Geographic Magazine. Dr. Shoemaker, you mentioned that article by Willie Benz in Nature, and the article said that that the comet wasn't supposed to be one solid body, but many fragments. And I just wonder whether or not the fact that there have been two confirmations of the plume is consistent with that theory. That is to say that I thought the fact that if the comet were made up of many smaller parts, that it would have just dissipated in the atmosphere and not created a plume like that.
Well, that was a conclusion drawn by Paul Weissman in a commentary on the article by Asfog and Benz predicting the Great Fizzle. And if the reports that we've received from Spain and Chile are correct, it's not a Great Fizzle. So you have to remember that the work by Asfog and Benz does not say whether the small pieces are successfully all re-aggregated into sort of essentially one clump for each nucleus, or whether they're spread out. But I think that the plume as reported is certainly consistent with these smaller pieces re-aggregating into one clump. That's what effectively hits the top of the atmosphere. One thing I would say is that if we should see these things at all, that it probably indicates we're dealing with larger objects than was concluded by Asfog and Benz. And I think we may have some up-to-date information from Heidi Hamel.
I'd like to introduce Dr. Heidi Hamel.
Eugene Shoemaker said he would be personally astonished if we saw nothing. Well, or if we didn't see something. Well, he's not going to be astonished. We actually saw some amazing things. Oh, boy. We just downloaded the first two orbits. In the first orbit, we were able to see a plume on the edge of the planet. In the second orbit, which I have a raw laser printer output, this is as raw as it gets, we can actually see the impact site itself. And I'll remind you, this is for A, the first one, not the brightest one. So we're going to have a really exciting week. So more details to come. We just got this data down. We haven't had a chance to do anything with it. And I'll be talking with you at 10 o'clock about what we have actually seen in the larger data set.
What's the wavelength, Heidi?
This is a methane filter at 889. Do you have a pencil or pen, something?
Yes.
I don't even have a piece of cardboard to have this mounted on. Okay, we just blew up a section of the planet. This is the southern pole here. You see there's a bright streak. See that bright streak? And around the edge of this streak, there's some other stuff. Stuff. Tell you more about the stuff tonight.
I think we may have some more questions here.
Wow.
Would you like to comment?
Well, I think you can all lay your worries to rest. Those reports from Spain and Chile are right. and I think that I'll personally bet another case of champagne with Brian Marsden that we've got big objects. Those are not puny. Not to show to see the effects that we're seeing, you have to put a lot of energy into the atmosphere. So I think we're very, very privileged tonight to see an event that's not once in a lifetime. It's once in a millennium.
I think, though, that Brian Marsden's efforts to come out on the smaller size were great, because we have had experiences where there's been a lot of hype for something, and then it turns out to be not what we're expecting. We have never seen this before. This is totally new ground. This is a totally new kind of thing in science that we're witnessing tonight. And Brian's argument made a lot of sense. It certainly made a lot of sense to me. We didn't buy it, but it made a lot of sense. And I imagine right now that Brian's as excited as the rest of us at what is happening. This is a wonderful time for everybody, I think.
I'd like to second that, David. I think Brian wanted to be on the cautious side, not to build up expectations too high. And I think that was a wise course of action on his part, and his role as the director of the CBAT, the Central Bureau for Astronomical Telegrams. That was the right course of action for him. And of course, he was betting on statistics, and we beat the statistics.
Yeah, we
beat the odds.
Do you have an estimate of the minimum diameter, guesstimate of the minimum diameter of Fragment A yet? Could you
of the single object or of the whole original object?
Fragment A, the one that Hubble just took that image of.
I would guess, just from the relative brightness and the limits that were placed earlier by the very careful work of Hal Weaver, that we're looking at an object that is of the order of 1 kilometer in diameter. That's its real diameter. And the bigger objects are really bigger. And the original object was really about 10 kilometers.
Can I ask one more question?
By the way, 10-kilometer object is not quite as large, as about 2/3 the size of Halley's Comet. So
No, that is the size of Halley's. The mean diameter of Halley's Comet is 10 kilometers.
all right, so we're talking about an object about the size of Halley's Comet. If this object were near the Earth, it would be big and not anymore, but it would be big and bright with a tail and everything. This is a big. Looks like this is a big object.
Can you just explain a bit why the radio wave would have increased as that report from Japan yesterday? Why would that happen with this?
Frankly, I don't think anyone made that prediction. We don't have a model. Maybe some people are inventing them right now. I'll bet Alex Dessler is working on 3 or 4 models. But, what we were going to see in the radio wave region was a grab bag. People are going to be looking, but really not knowing how to predict it theoretically.
We have time for just 1 or 2 more questions down here.
Glenda Chu from the San Jose Mercury News. I wonder if the fact that these impacts seem to be occurring maybe 13 minutes later than predicted is also good news, in the sense that they must be occurring closer to where you all can see them. And do you know how, if they are 13 minutes later than thought, how far away from
the limb?
Rotating into our view are they then?
It doesn't change the actual impact point relative to our line of sight by very much. It just means the comet's coming a little bit later on its trajectory, but it won't shift it by very much.
Yeah. Another thing about the sizes, if it turns out that everyone's right and that this is close to a 10-kilometer object, I really want to mention Zdenek Sekanina, Paul Chodas, and Don Yeomans at JPL that have been saying all along that their models show a large comet before breakup 2 years ago. So if this turns out to be true, this is a real mathematical victory for them. Yeah.
Question in the back.
Miles O'Brien with CNN. I know from over here. I know from speaking to you all this past week that you had a fair amount of anxiety about what might happen tonight. Give us a sense of how much relief this just recent announcement gives you.
Miles, would you like to have some campaign here with us?
You probably can't tell that we're very happy. It's a champagne experience.
I'm absolutely thrilled to pieces. It's such a rare night when nature calls you on the phone and says, I'm going to drop 20 comets into Jupiter at 138 miles an hour. All I want you to do is watch, and I'm not going to tell you what's going to happen in advance, just watch. We are watching with everything we've got tonight, and nature winked at us. It's exciting.
You can imagine that we've all worried about the Kohoutek effect and wondering whether we'd have to slink off and hide under a flat rock somewhere. I think the answer is we're not going to have to hide under a flat rock.
Exceeded your wildest expectations?
Yes, but not our wildest hopes.
We have 2 more minutes to go. We'll take a question up here in front. Here we go. Right. Name and affiliation, please.
Yeah, Paul Reeser with AP. If this is one of the smallest, what is the largest, and when do you expect it to hit?
Some of the largest fragments are G, H, and K. And I think you have a press kit, Don, don't you, that
Yes,
has all of the times? I hate to give you them all. I don't have a table in front of me.
Available.
They are available in the press kit, and G and H will be coming down in a couple of days. And K, what? Thank you. Thanks. There's Hal Weaver.
The one I'm personally excited about is Q. That's the president of the Gang of Four, the former Gang of Four. One of them kind of faded out. And another one split, so we still have a Gang of Four. That happens on July 20th, which is the 25th anniversary of the moon landing. It's a very complex group of fragments, and they're all going to be hitting within a very short time.
I think we ought to recognize Hal Weaver, who's standing right back there and spoke up. Hal is the one that made the estimates from the Hubble images a year ago in July and came out with these estimates of the largest 9 being about 3 kilometers, maybe the very biggest 4. And I think he ought to be feeling pretty high tonight. I hope he's got a whole bottle of champagne himself.
I'm afraid we've run out of time right now for question and answer, and the Shoemakers have another engagement they have to...
We're going to run down and watch the impact of Fragment B at the Naval Observatory right now.
We will have our panel again tomorrow morning at 10 o'clock at the Goddard Space Center, and also we'll have some updates later this evening at 10 p.m. with Heidi Hamill and the other science team members, if you would care to join us for that. 10 o'clock tonight Eastern. Thank you very much.
Got a burning question.